Many of you have been having problems with several questions that thankfully all relate to just a single skill. The good news is that if you master this one skill, that you will be able to answer all 5 or 6 or 7 or so of these problems that you are struggling with. So what is that skill? Well, I'm going to teach you how to do these problems in 2 ways. All of these problems have this basic form. If you change one quantity, then how does another quantity change? For example, if you change x, how does y change? If you change the height of an object, for example, then how does its potential energy change? If you change its speed, then how does its kinetic energy change it? Here's the easy way. The easy way to figure out these problems is just by memorizing these 3 simple rules. Now, keep in mind that this is a limited way to do these problems because it's not going to apply to every single problem that you come across. It'll apply to most of them, probably about 80 to 90% of the problems that we're going to see. If you want to answer 100% of them, you're going to need to learn the why. But the easy way just tells you what to do without explaining why. So here's the easy way. We have 3 different types of equations. The first type looks like that. ma equals F, mgh equals potential energy, force times distance equals work. And you notice that all the variables are on the same quote-unquote level. M, A, and F are all in the numerator. Same for mg and h and the potential energy, same for force, distance, and work. Not so for type 2 problems. Type 2 problems have a variable in the denominator, m or t in these 2 cases. Type 3 problems, we're only going to see, so far, one equation that looks like this. 1/2 mv squared equals kinetic energy. And in this case, we have one variable that is raised to the 2nd power. So here's what distinguishes the 3 types. In type 1, we have all of the variables on the same quote-unquote level. They're all in the numerator. In type 2, one of the variables is in the denominator. Type 3, one of the variables is raised to the 2nd power. All right, so rule number 1 deals with type 1 equations. So you might see a problem like this. The rule rather is that both sides change in the same way. So for example, you might see a problem like this. If you double m, then what happens to the potential energy? You double it. If you double m, the potential energy doubles. That's rule 1. Now note that there is a caveat, there is a condition that you have to remember. All the other parts of the equation have to stay the same. G can't change, H can't change. Rule 1 does not apply if G and H change. Rule 2 applies to equations of type 2. In Rule 2, the change on the left is going to be opposite to the change on the right. So, for example, if you double t, if you double the time, you have p. The change on the left is the opposite of the change on the right, the reciprocal. Again, we have the exception that work can't change. If work does change in the problem, then this rule does not apply. Rule 3 applies to equations of type 3. Here's Rule 3. The change on the right is the square of the change on the left. Again, that's the change on the right is the square of the change on the left. Now, what does that mean? For example, if you double v, so v is now 2 times v, or 2v, then you get 2 squared, or 4 times the kinetic energy. Again, double v, 2 squared, or 4 times the kinetic energy. Finally, the caveat again, mass can't change. That's why these rules are limited. Now here's the hard way. The nice thing about the hard way is that it's universal. You might run across a question like this. If you double the height of an object, how does its potential energy compare to before? The key word is compare. Whenever you see that word compare, you know you're dealing with a question that relates to this skill. So let's translate that. If H changes, how does potential energy change? All of these questions are asking a question of that form. Well, let's figure it out. There is the formula for potential energy, which relates height and potential energy. Now what do we do? You don't know the mass, many of you are saying. You don't need to know the mass. Here all I'm doing is doubling the height. 2h is equal to double the initial height. Now, all I'm going to do is move that 2 to the left. So now I'm saying that mg times the quantity 2h is equal to 2 times the quantity mgh. If you don't believe me, check. Does 1 times 2 times the quantity 3 times 4 equal 3 times the quantity 1 times 2 times 4? I'll leave that up to you to figure out. But notice now, I have something very significant. mgh is equal to the potential energy. Again, mgh is equal to the potential energy. 2 times mgh is equal to 2 times the potential energy. So, by doubling the height, I doubled the potential energy, and I just proved it mathematically. If you don't believe me, check. Plug in some numbers. Make your own pick if they don't give you the values in the problem. I'm going to set my mass equal to 1 kilogram. I am going to set my height equal to 1 meter. I'm going to say that g is equal to 10 meters per second squared. And check it out. 1 times 10 times 1 gives you a potential energy of 10 joules. Now I'm going to double the height. H is going to be 2 meters now. 1 times 10 times 2 meters is equal to 20 joules. 10 and 20, how are they related? If you double the height times 2, 1 meter to 2 meter, you've just doubled the potential energy, right? One final example. Let's say you run across a question like this. This would be the hardest type of question you're going to see for now. If you double the speed of an object, how does its kinetic energy compare to before? Translate the problem. If v changes, how does the kinetic energy change? Well, let's see. There's your equation. Now, double v, 2v, right? All I did there was just double the speed. 1/2 m times the quantity 2v squared. 2 times v is double the speed. That is equal to 1/2 m times the quantity 4v squared. All I did was square the term 2v. And now all I'm doing is moving the 4 to the outside of the parentheses. And I'm saying that 1/2 m times the quantity 2v squared is equal to 1/2 m times 4v squared, which is equal to 4 times 1/2 mv squared. We're almost there. 1/2 mv squared is kinetic energy. I've just proven that if you double the speed, you get 4 times the kinetic energy. Double the speed, 4 times the kinetic energy. Not twice the kinetic energy, but 4 times the kinetic energy because v is squared. That's it. If you have any questions about any of these examples, write down your specific questions so that you can ask me in class.